The Great Pyramid of Giza was built in the 2600s BC with flawless mathematical planning. The margin of error at its square base was 1 in 14,000, and the error in its right angles was a mere 1 in 27,000. But there is a great historical mystery here. There is not a single mathematical papyrus surviving from the Old Kingdom period regarding the mathematics used while erecting these flawless structures. All we have left are some guidelines on walls and ivory labels. So, how was this unwritten mathematical perfection applied on the construction site? Entering the 10th year of construction at Giza, there was no towering, pointed pyramid yet. The structure rising towards the sky was a colossal mass with a wide base and a completely flat top. Geometrically speaking, it was a perfect truncated pyramid. But exactly how many tons of stone had been laid at this stage of construction? How much more stone was needed to complete the rest? To manage the immense static pressure bearing down on the lower chambers, royal scribes had to flawlessly calculate the volume of this half-finished giant. Hundreds of years after Giza, we travel to the Middle Kingdom period in the 1850s BC. On the throne sits Pharaoh Amenemhat III, an engineering enthusiast who commissioned massive dams and labyrinthine temples, calculating in advance how much mud brick or labor would go into such colossal constructions rested on the shoulders of the royal scribes. However, in the Moscow Papyrus, dating from this period, and discovered by Golenischev, do not expect a spacious and orderly textbook 32 centimeters wide like the Rhine Papyrus we saw in our first video. The document before us is a papyrus 5.5 meters long, but only a few centimeters wide, shaped like a very narrow strip. It doesn't even have an instructional order. It contains 25 ruthless questions arranged randomly, from PEFSU problems, calculating bread and beer exchanges, to Baku labor problems, measuring the working speed of shoemakers, to ship mast calculations. It is essentially a rigorous exam paper that measures skill rather than teaching it. In 1917, when researcher Boris Turayev analyzed the 14th problem in the papyrus and presented it to the scientific world, everyone was shocked. This was the exact formula for the volume of a truncated pyramid used to find the volume of those massive half-built pyramids. However, the anonymous scribe provided no theoretical explanation or proof for the formula. As if giving a recipe, he directly listed the calculation steps. Square the lower base, multiply the lower and upper base together, square the upper base, add these together and multiply by 1/3 of the height. But how did the anonymous scribe find this flawless equation when there was no proof at all? Although researchers have proposed various spatial theories, we now want to do our own brainstorming with you. Could the Egyptian architects have thought of those complex numbers in the formula not abstractly, but completely physically in the following way? Pay attention to the scribe's steps in the formula: the square of the lower base, the square of the upper base, and the product of the two. Did the scribe imagine 3 different molds of the same height in his mind? One as wide as the lower base, one as small as the upper base, and the other a rectangular prism that is a hybrid of the two. Now imagine that we filled these 3 molds to the brim. Then let's pour all 3 into one giant container. We now have the total volume of these 3 shapes. Next, we distribute the liquid from this main tank into 3 different molds sharing the exact same height as the pyramid, namely H. One with the dimensions of the lower base, one with the dimensions of the upper base, and the third being a rectangular prism that is a hybrid of the two. And here is that miraculous moment. The water from the main tank fills these 3 different prisms to the absolute brim, down to the exact millimeter. This shows us a fascinating truth. The sum of the volumes of these 3 prisms is directly equal to the mass of 3 truncated pyramids. The formula we get when we factor out $H on the screen actually represents the total volume of 3 truncated pyramids. And that is precisely when the scribe's magical touch takes place. When he divides this threefold mass in his hands by 3, in other words, taking H divided by 3, what remains is nothing less than the unwavering perfect formula for a single truncated pyramid. This physical experiment was the algebraic formula itself. When he finished the calculation, the anonymous scribe noted this confident sentence on the papyrus, harboring no doubts. "Look, this is 56. You will find it to be correct." This was not a momentary experiment. It was the unshakable truth of that standard algorithm whose accuracy had been taught in scribe schools for centuries since the construction of Giza. The intelligence of the Egyptians knew no bounds in measuring the physical world. But what if they needed to find a mysterious value they did not have in their hands? How did the Egyptians solve that first-degree unknown, which we call X in modern mathematics, with the word aha, meaning heap? See you in the next episode, where we will witness the birth of primitive algebra. Stay with math.